Thanks for tuning in to another physics lesson with Mr. M, also known as the Scientific M. And in today's physics lesson, we're going to be taking a look at how we can solve for series circuits. And so in our example problem here, basically what they want us to be able to find for our given circuit is we want to be able to solve for its total resistance, its total current, and the voltage drops at each resistor. And so I'm going to give you a lesson on how we can do that. Before we begin though, with these series circuits, quick review here with our circuit diagram. How do we know that this is a series circuit? Well, if you recall, a series circuit, the electricity only has one path that it can follow. So as we take a look at this circuit diagram, we can see that the electricity only has one path to follow. Okay, and as you go along with solving these types of problems, you may see that where you're going to put your answers may look something similar to this, where it looks like you got a lot of work to do here. This is a nice way to organize all of your answers if it's not like that already. But let's go ahead and dive into how we're going to solve this. Before we do that though, there's a couple of rules that we have to follow when solving for these series circuits. There's basically a rule for resistance, a rule for current, and a rule for voltage. And so I just want to take a look at these real quick, and we're going to see how they're related to Ohm's law. And so when solving for resistance, the rule with series circuits is that all you have to do is you have to add up all of the resistors. And in our circuit diagram, the resistors look like that squiggly line right there. So the way that we show this mathematically is we would say R1 plus R2 plus R3, and if you have got more, it's the same thing. You just add them all up. Now to solve for total current in a series circuit, because there's only one path for electricity to flow, at each resistor the current stays the same. So to represent that mathematically, we say that the total current is equal at each of the places on the circuit. So we would say our total resistance is equal at 1, at spot 1 is equal to spot 2 is equal to spot 3, and so forth. And then our voltage, our total voltage, or our change in voltage for a series circuit is similar to that of solving for the resistance, where our voltage drops at each of our resistors will add up to the total voltage. So we just got to add them up to get our total. Okay, so we're going to use these three rules in addition to Ohm's law, as I mentioned, and if you recall, Ohm's law is V equals IR, so we're going to be able to use this equation with our three rules. Okay. So with that being said, let's take a look at our diagram that we have here. We have some given information already. We see that we're working with a 60-volt battery, and we have information for each of our three resistors. So one of the things I teach my students is we should always write down the given information that we have. So we know that our total voltage is 60 volts. So we're going to put that in here, 60 volts. And we know that our resistor 1 is 17 ohms, resistor 2 is 12 ohms, and resistor 3 is 11 ohms. And so our objective then is to solve for all of these open areas. Okay. So with that, one of the ways that I believe is the best way to go about starting these problems is you always want to try and solve for the totals first, like total resistance and total current or total voltage. Try and get those first, and then everything else will kind of come after that. Okay, so one of the things that we can solve for is we can solve for our total resistance, because all we have to do is add up our 3 resistors and we have that information. So to get this total resistance right here, we're just going to add our 17 ohms plus our 12 ohms and our 11 ohms. And when we do that, we get a total of 40 ohms. Okay, so we can fill in that blank. And as I mentioned, as we solve for each of these totals, we're going to come back to this equation right here. So as you see, I've got my total resistance and I've got my total voltage. So my missing unknown, or my unknown value for the total, is the total current. Well, let's just go ahead and plug that in to V equals IR, and we can then solve for our total current. So our voltage here is 60 volts. That's going to equal our current times our resistance, which is 40 ohms. So to get I by itself, we're going to divide by 40 on both sides. When we do this, our total current is going to equal 1.5 amps. Okay. This is valuable information. We can plug that in right here, 1.5 amps. Now that we know the total current, let's go back to our rule, which states that the current at every single place is the same. So if my total current is 1.5, well, my current at the first resistor also has to be 1.5. So we can fill in all of these because the current is the same at every single position. Okay. Now all we're left is to solve for each of these velocity drops, okay, which basically is telling us, not velocity drops, our voltage drops, which is telling us how many volts are being used as the electricity flows through all of these resistors. Okay, and the way that we do this, just like how when we used our Ohm's law for the total resistance, total current, and total voltage, at the first resistor, we're going to have to do that the same. We have to, for V equals IR, we have to do the resistor 1 and current 1 to get voltage 1. To do it for the second one, we have to do all of the second resistor, all of the third resistor. So we can't intermingle our resistors and our total values. Okay. So to find this first voltage drop, we're going to be using our 17 ohms and our 1.5 amps. And with our equation, it's very simple. We're just going to multiply these two because it's going to be our current times resistance. Okay, and so to show you this, so V1 is going to equal our 1.5 amps times our 17 ohms, and that's going to give us a total voltage of 25.5 volts. Now for our second voltage drop, it's still the same, 1.5 amps, multiplied now by our 12 ohms, and that's going to give us a voltage drop of 18 volts. And then our last voltage drop, our third one here, is going to be 1.5 amps times our 11 ohm resistor, which gives us 16.5 volts. Okay, and so now we can just complete our chart. Voltage 1 was 25.5, voltage drop 2 was 18, and voltage drop 3 was 16.5. Okay. So in review, when dealing with these series circuits, we have to keep in mind our 3 rules. For resistance, we add them all up to get the total resistance. For current, the current's the same at every point in the circuit, and we have to add up all of our voltage drops to get the total voltage. We use this in relation to Ohm's law to solve all of our missing values. So hopefully this video was helpful for you in solving your own series circuit problems. Thanks for tuning in.